Hi all, welcome to our class. We studied trigonometric identities. In this class, we are going to discuss some problems related with the trigonometric identities. First question, prove that cot theta minus cosec theta all square is equal to 1 minus cos theta divided by 1 plus cos theta. We have to prove that cot theta minus cosec theta all square is equal to 1 minus cos theta divided by 1 plus cos theta. Before that, I am going to write our identities. We have first identity sin square theta plus cos square theta which is equal to 1. This is the first identity. Sin square theta plus cos square theta is equal to 1, or sin square a plus cos square a is equal to 1. Then from this we will get another two identities. First one, sin square theta is equal to 1 minus cos square theta, and cos square theta is equal to 1 minus sin square theta. Second identity is c square theta minus tan square theta which is equal to 1. C square a minus tan square a is equal to 1. Here we use theta. So c square theta minus tan square theta which is equal to 1. And one more identity, cos square theta minus cot square theta which is equal to 1. From this also we will get three more identities. So cos square theta minus cot square theta is equal to 1. Then we have studied sin theta is equal to 1 by cosec theta, or cosec theta is equal to 1 by sin theta, and sec theta is equal to 1 by cos theta, cos theta is equal to 1 by sin theta, tan theta is equal to 1 by cot theta, or cot theta is equal to 1 by tan theta. And we also studied sin theta by cos theta. Sin theta by cos theta is equal to tan theta, or cot theta by sin theta is equal to cos theta by sin theta is equal to cot theta. These are some important results we have studied in this chapter. Using these formulas, we are going to prove this question. Cot theta minus cosec theta all square is equal to 1 minus cos theta divided by 1 plus cos theta. So, first step is, this is the LHS and this is the RHS. Left side of equation, this is the right hand side of the equation. So, I am going to take LHS and simplify LHS and prove that it is equal to RHS. That is the method. Take LHS and simplify LHS and prove that is equal to RHS. So LHS is equal to cot theta minus cosec theta all square. I took LHS. LHS is cot theta minus cosec theta all square, which is equal to our RHS is 1 minus cos theta divided by 1 plus cos theta. So the relationship between sin square theta plus cos square theta which is equal to 1. So here cot theta minus cosec theta all square, we have to prove 1 minus cos theta divided by 1 plus cos theta. So we are going to change cot and cosec in terms of cos or sin, because sin and cos are related. So we can change this cot and cosec in terms of cos or sin. So this is equal to cot theta is equal to, we know cot theta is equal to cos theta by sin theta. So I am going to write, instead of this cot theta, I am going to write cos theta minus cos theta by sin theta. Cos theta by sin theta minus cosec theta all square. Cosec theta, we know cosec theta. We can change cosec theta in terms of cos or sin. How? Cosec theta means reverse reciprocal of sin. So cosec theta means 1 by sin theta. Isn't it? Cosec theta is equal to 1 by sin theta. The square is the all square. So we change this cot theta into cos theta by sin theta minus 1 by sin theta. Cosec theta is the reciprocal of sin. So cosec theta is equal to 1 by sin theta all square, which is equal to cos theta. Here sin theta, both are fractions, denominators are same. So subtract the numerators. Cos theta minus 1 divided by sin theta. Cos theta minus 1 by sin theta. So cos theta minus 1 by sin theta all square, which is equal to cos theta minus 1 all square means sin theta cos theta minus 1. Here square, this square for both numerator and denominator. So cos theta minus 1 square by sin square theta. Cos theta minus 1 by cos square sin square theta. So we changed this cos theta into cos theta by sin theta, cosec theta into 1 by sin theta, then simplification cos theta minus 1 by sin theta, which is equal to cos theta minus 1 all square by sin square theta, which is equal to cos theta minus 1 all square means this cos theta minus 1 we can change is correct 1 minus cos theta all square, 1 minus cos theta all square. When we take minus outside, then minus outside you will get minus outside, then plus cos theta will become minus cos theta, minus 1 will become plus 1, then all square, then minus square plus. So we can say that is minus 1 minus cos. First I wrote 1, then minus cos theta all square. This minus square will become plus, then we will get 1 minus cos theta all square. So we can write cos theta minus 1 all square is also equal to 1 minus cos theta all square, because here square, when we take minus outside, this here square is there, therefore minus will become positive, then 1 minus cos theta all square divided by, look at here, sin square theta. We know sin square theta plus cos square theta is equal to 1. Therefore, cos sin square theta is equal to 1 minus cos square theta. So, sin square theta is equal to 1 minus cos square theta. Instead of this sin square theta, I wrote 1 minus cos square theta. So, 1 minus cos theta all square divided by 1 minus cos square theta, which is equal to 1 minus cos square, 1 minus cos theta all square by 1 minus cos square theta. Look at here. Here 1 minus cos square theta. 1 means 1 square. Let us consider as a 1 square. 1 square is also 1. Therefore, this is 1 square minus cos square theta. This is in the form a square minus b square. That is 1 minus 1 square minus cos square theta, which is equal to 1 a square minus b square, a plus b into a minus b. That is 1 plus cos theta into 1 minus cos theta. A square minus b square is equal to a plus b into a minus b. Therefore, 1 square minus cos square theta. 1 square minus cos square theta is 1 plus cos theta into 1 minus cos theta. So, I am going to write 1 minus cos square theta is equal to 1 plus cos theta into 1 minus cos theta. So, which is equal to, and 1 minus cos theta all square. 1 minus cos theta all square means a square means a into a. 1 minus cos theta all square is equal to 1 minus cos theta into 1 minus cos theta. So I wrote 1 minus cos theta into 1 minus cos theta. That is 1 minus cos theta all square. So we are going to prove this is equal to this. That's why we are going to change these types of arrangements. So 1 minus cos theta into 1 minus cos theta divided by, here 1 minus cos square theta. 1 minus cos square theta means a plus b into a minus b. That is 1 plus cos theta into 1 minus cos theta. Here 1 minus cos theta, here 1 minus cos theta. We can cut this 1 minus cos theta and 1 minus cos theta, which is equal to here 1 minus cos theta divided by here 1 plus cos theta. Therefore, which is equal to this RHS. So, by changing cos theta and minus cosec theta, we can change this LHS into RHS. That is 1 minus cos theta by 1 plus cos theta, which is equal to RHS. Another question, prove that cos raised to 4a minus cos square a, which is equal to sin raised to 4a minus sin square a. This is LHS, this is RHS. We have to prove this is equal to this. So, our first step is take LHS and simplify LHS and prove that which is equal to RHS. So LHS is equal to cos raised to 4a minus cos square a. So after simplifying this, we have to know that this is equal to sin raised to 4a minus sin square, which is equal to cos raised to 4a minus cos square a. Here cos raised to 4a, here cos square a, here cos square a is there, here also cos square a is there. We can take cos square a outside. So cos square a outside. Then cos raised to 4a, when we took cos square a outside, then remaining is cos square. Cos square a into cos square a, cos raised to 4a. Therefore cos square a minus here cos square a. Cos square a, when we take cos square outside, remaining is 1. So first step is taking cos square a outside, which is equal to cos square a into cos square a minus 1. Look at the RHS. Here sin raised to 4a minus sin square a. So we have to change this cos into sin. So here cos square a, here cos square a. We can change this cos square a into sin square a. We have the identity sin square a plus cos square a, which is equal to 1, or cos square a is equal to 1 minus sin square. So using this identity, we can change this cos square a in terms of sin square. So cos square a is equal to 1 minus sin square. So instead of this cos square a, I am going to write 1 minus sin square. So 1 minus sin square a into here cos square a minus 1. Here also I am going to change this cos square a into 1 minus sin square a. Therefore 1 minus sin square a. Here minus 1 is there. 1 minus 1. So 1 minus sin square a minus 1, which is equal to 1 minus sin square a into 1 minus sin square a minus 1. Here 1 minus 1. 1 minus 1, 0. Remaining is minus sin square. Minus sin square. So which is equal to this minus sin square we can multiply with the bracket minus sin square into 1, that is minus sin square. Minus sin square into minus sin square, that is minus into minus plus sin raised to 4. Which is equal to, we can write the positive term first. Therefore sin raised to 4 first. So, sin raised to 4 plus minus sin square. Second we wrote minus sin square. Look at the RHS. Sin raised to 4a minus sin square. Sin raised to 4a minus sin square, which is equal to RHS. So we can prove cos raised to 4a minus cos square is equal to sin raised to 4a minus sin square. Another question, prove that cos raised to 4a minus cos square which is equal to sin raised to 4a minus sin square. This is LHS, this is RHS. We have to prove this is equal to this. So our first step is take LHS and simplify LHS and prove that which is equal to RHS. So LHS is equal to cos raised to 4a minus cos square a. So after simplifying this, we have to know that this is equal to sin raised to 4a minus sin square, which is equal to cos raised to 4a minus cos square a. Here cos raised to 4a, here cos square a, here cos square a is there, here also cos square a is there. We can take cos square a outside. So cos square a outside. Then cos raised to 4a, when we took cos square a outside, then remaining is cos square. Cos square a into cos square a, cos raised to 4a. Therefore cos square a minus here cos square a. Cos square a, when we take cos square outside, the meaning is 1. So first step is taking cos square a outside, which is equal to cos square a into cos square a minus 1. Look at the RHS. Here sin raised to 4a minus sin square a. So we have to change this cos into sin. So here cos square a, here cos square a. We can change this cos square a into sin square a. We have the identity sin square a plus cos square a, which is equal to 1, or cos square a is equal to 1 minus sin square. So, using this identity, we can change this cos square in terms of sin square. So, cos square is equal to 1 minus sin square. So, instead of this cos square, I am going to write 1 minus sin square. So, 1 minus sin square into here cos square minus 1. Here also I am going to change this cos square into 1 minus sin square. Therefore, 1 minus sin square. Here minus 1 is there. 1 minus 1. So 1 minus sin square minus 1, which is equal to 1 minus sin square into 1 minus sin square minus 1. Here 1 minus 1. 1 minus 1, 0. Remaining is minus sin square. Minus sin square. So which is equal to this minus sin square we can multiply with the bracket. Minus sin square into 1. That is minus sin square. Minus sin square into minus sin square. That is minus into minus plus sin raised to 4. Which is equal to, we can write the positive term first. Therefore, sin raised to 4 first. So, sin raised to 4 plus minus sin square. Second, we wrote minus sin square. Look at the arches. Sin raised to 4 minus sin square. Sin raised to 4 minus sin square, which is equal to arches. So we can prove cos raised to 4 minus cos square is equal to sin raised to 4 minus sin square.